Section 11.1 is going to discuss parabolas. Now, parabolas have a lot of nice applications. Here's the general shape of a parabola. Let's look at some of the things that you'll see in a parabola, where you could actually see a parabola. So let me kind of start all over at the beginning here. Parabolas are part of something called conic sections. And I really marvel at the Greek mathematicians a couple thousand years ago sitting around a little campfire saying, hey, I got this great idea. Let's put two cones tip to tip and then slice them with a plane and see what kind of intersection you get. Well, the kind of intersections that you get happen to be exactly the stuff that we're going to be studying in this chapter. If you slice parallel to the sides of one of the cones, you'll get a parabola. Perpendicular to the axis of symmetry, you get a circle. Incline that a little bit, you get an ellipse. And then parallel to the axis of symmetry, but removed from the center, you get a hyperbola. Wow. So lots of neat things, but they have all kinds of applications. You'll see them everywhere, including the icon in Michigan, the Mackinac Bridge. The suspension cables are in the shape of a parabola. Isaac Newton used a parabolic-shaped mirror to build his telescope, helped prove his theory of light. Radio telescopes use a parabolic shape to capture distant gossamer waves from all over the universe and collect them, and they focus them at this one point. And that focus is going to be something we're going to have to calculate, is to find that. By the way, these things are incredibly sensitive. If you were on the moon and sparked up a cigarette of the wacky tobacco that the state of Michigan made legal a couple years ago, they'd be able to spot the flare. That's how sensitive they are. They could tell where you're at just by you striking a match. Just amazing. Focus is one place we're going to look at. In fact, this is not a bad thing to look at, and to show some of the properties of a parabola that we're going to work with. The focus is going to be a distance of p away from the vertex, and then p in the other direction is going to be the distance to the directrix. Now, at the same time that the vertex is equidistant from the focus to the directrix, the focus is equidistant between a point on the parabola, any point on the parabola, and the directrix. So this gray line here to the focus from the parabola, and this gray line from the parabola to the directrix have the same length. And we'll look at that in just a minute. A lot of times projectile motion, of course Angry Birds, has a parabolic shape. The Hubble Space Telescope, yay, wow. Our Eyes to the Universe, billion-dollar telescope, being worked on by Andrew Feustel. Andrew Feustel is an OCC graduate. When we say you can get anywhere from here, we mean it. Woohoo! Oakland Community College, good on us. How about that? So here's his bio if you want to read some more about that. Sustainable lighting, put on a parabolic-shaped mirror on the roof of a building, and then use fiber optic cables to bring in sunlight into the interior of the building. Car headlights, searchlights use parabolic-shaped reflectors. Parabolic microphone to capture the sounds and grunts and groans of Monday Night Football. And my personal bucket list item, the Vomit Comet. A parabola, or a plane that travels in a steep angle of attack and forms a parabolic arc at the top. And during that little parabolic arc, you'll experience weightlessness. Now, what's funny about this picture on the bottom left? Somebody brought a cat, which I just find hilarious. But $5,000 a pop if you got the money, man, that's on my list. And then this is a nod to the next conic section, which is going to be an ellipse, because comets travel in an elliptical shaped orbit. But I digress. Let's get back to parabolas. We know that this distance here is going to be a distance of p, the distance between the focus and directrix. And I didn't go through and show it, but let's scroll down here on this website and turn on this point right here, or this part right here, and it shows you that no matter where you are, that the distance between the parabola and the focus and the directrix is the same. So pretty cool. That's how you define a parabola. Now, let's actually find some of these equations. So going back, we'll do examples D, E, and F. So we'll start out here. Find the equation for a parabola that has a vertex at the origin and satisfies this given condition. The focus is at -7 and 0. So go to your other link on parabolas. We'll type in our vertex here, our focus here, and let's label them as well. Now that tells me a couple things here. Just this much right here. First of all, of the 4 different possibilities here, that has a parabola that opens up, down, left, and right, it has to be one that opens to the left, because the focus is always going to be on the inside of a parabola. So it has to open around the focus and away from the directrix. Now the fact that our focus is at -7 and 0 tells us the distance P right here. That distance is 7. That means in the other direction, it also has to be 7. So this distance right here has to be the same. It's also 7. And that tells me where to plant my directrix. So that would be at x equals 7. Yay. Now between those, let's see if we can't figure out then what would be the equation of the parabola. All right. Well, I know a couple things about this. I know that it has to open to the left, and it has a vertex at 0, 0. It's going to be of this form. Y squared equals 4 times P times X. But we know P equals 7. I'm leaving a little space there if you'd like. So Y squared equals 4 times 7 times X, which is 28X. And yeah, there's something wrong, other than the fact that I forgot the squared there. And that something wrong is that this is going to open to the right, not to the left. What's going to make it open to the left? A negative. So if you want to put the negative here, that's fine. Typically, I just go back and look and see, do I need the negative in here? And yeah, I do. So y squared equals -28x. That would be our equation. It's going to be a very wide opening parabola, because if you solve for this, really you're going to get 1/28 or -1/28 y squared equals x. So that small coefficient there is going to make it open very wide. We can actually put that graph in here just to kind of look at it real quick. So let me just enter it in here. Y squared equals -28x. There you go. And it matches our expectations. It opens to the left, it opens around the focus and away from the directrix. If you forgot the negative, hopefully you'll see that right away, that there's a problem. Your parabola should not open through the directrix. So nice that you have decimals. You can graph this kind of stuff on the graphing calculator. It's just that you'd have to solve for y to do that, and then it'd end up being 2 cases, a positive and negative case that you have to graph separately. It's a pain. I'll put a handout in D2L. Let's shut these down and do a couple more. Let's try example F. Example F gives you this right here. And let me see if I can't make that a little bit bigger for us. There we go. That looks good. Now the focus is some distance away from the vertex, but we don't exactly know what that is. But there's this line across here, and I think the formal name for this line is the latus rectum, if you were to look it up in Google. But your book and web assignment refer to it as the focal diameter. I like focal diameter much better. So let's see if we can't figure some things out about this. Now, in general, the thing that you need to know is this distance all the way across would be like the diameter of a circle, diameter of this parabola right here. And that distance across is going to end up being 4 times P. So let's see if we can't figure out the focal diameter for this one. And then See if we can't use it to come up with the equation. So this is example F. So focal diameter. Well, the focal diameter is going to have to be 5/2 plus 5/2. So 5/2 plus 5/2. And that's going to equal 10/2, which is just 5. Well, okay, that's cool. Focal diameter is 5. But I also know that the focal diameter is always equal to 4 times p. So that gives me an equation I can solve. 4 times p equals 5. P equals 5/4. Yay. Let's plug that into the correct equation. This parabola has to open to the left, so it has to be a parabola of this form. And it's also going to have a negative in it as well. So if I do y squared equals 4 times 5/4 times x, I end up with y squared equals 5x. And I know that's pretty close to being right, but it's not exactly spot on. The thing that I'm missing here is the negative. And you can play around with the mental gymnastics to keep track of the fact that this is technically negative, or you can just add a negative here at the end. It's up to you. How's that one looking? Good? All right. Let's try one last one here, and it's one that I stole from your homework. You know, I think I've got this one on, yeah, here we go. Let's shut off these from up above. Here's your equation, and there's your focal diameter. So it works out pretty nice. Okay, the last one that we want to look at, we'll jump down to, let's see, it was example H. And example H is a little bit different. They don't exactly tell you what P is, but they do give you a little bit of a hint. So let's see if we can't figure out based on the hint. They give us a little square in there, and they tell us that that square has an area of 36. So let me kind of draw this as best I can. So I'll copy that. Okay, so kind of coming over to here. So here's our parabola. Vertex, excuse me, no, I drew this wrong, didn't I? Yeah. Yeah, I drew that wrong. My bad. Let me try again. Okay. So this time I think I got it right. You've got a parabola that opens to the right at the origin. And the thing that they tell you that's going to help you is they tell you this square area. And that square area is 36. Area equals 36. Now, I also know a different expression for that area. Since it's a square, both of these sides have to have the same distance. In other words, p squared equals 36. So that means p equals plus or minus 6 when you take plus or minus a square root. And since this parabola is going to open to the right, we're going to want to take the positive square root. Y squared equals 4 times p times x. Y squared equals 4 times 6 times x, or 24x. And that's your equation. Sweet. I like that one. kind of a different spin on some of these things. Okay. Looking good. Excellent. Yeah. Good question. So the distance here is 6, so that gives me x equal -6. And the distance here would also have to be 6, so 6, 0 would be the focus. Yeah, thanks, Carl Espy. Excellent. And that's pretty much all that we could ask for in terms of a parabola at this point. Now, eventually, what we're going to do is we're going to start moving this around. We're going to have to move away from the origin, but the orientation of everything is going to stay the same. That is, the focus is going to lie inside the parabola. This distance here is going to be p. You're going to have a directrix that the parabola opens away from. So all that's going to stay the same. It's just going to be shifting the center around a little bit. Excellent. Thank you.